Let's talk about practice problems and look at 10 different practice problems dealing with elimination reactions and competition between elimination and substitution reactions. We'll go to the next slide. I'll give you some problem strategies and perhaps help explain how the answer can be arrived at. Here's the first one. Which alkyl halide will react most readily under E2 reaction conditions with sodium ethoxide? Now, after I read the question, I'm going to pause for just a second, and you can take a look at this problem and propose an answer. So let's stop right at this point. Pause the podcast. Okay, take a look at this problem. First, it indicates we have sodium ethoxide. Sodium ethoxide, you've got the ethoxide ion that's available to serve as a base to remove a hydrogen. This is a dihydrohalogenation reaction. Halogen and a hydrogen are going to be removed through some type of elimination reaction, E2, it's told. Iodine is the best leaving group. So A, B, and C are out of consideration. So all we need to do is figure out if it's D or E. By Zaitsev's rule, the beta carbon with the fewest hydrogens will lose one hydrogen to form the alkene. Now D, if you look at D, D does not have any hydrogens on the beta carbon. 0 hydrogens. So E2 cannot occur with D. Therefore, the correct answer must be E. And E, in fact, has 8 hydrogens that can be readily abstracted by the ethoxy base from the beta carbons. Okay, let's go to the second problem. Okay, in this one, in the following reaction, which base will most favor the anti-Zaitsev's product? So let's pause for just a moment and take a look at that problem. Now, as you can see here, they've actually highlighted two of the answers, giving you an idea of what is happening here. We've got the number one. It wants us to. It says in the following reaction, which base will most favor the anti-Zaitsev product? Of course, anti-Zaitsev means that the base will remove a hydrogen from a beta carbon that has the most hydrogens as opposed to the fewest. And that will create the products that are circled or that have the square around them right here, as opposed to the one on the right, which would be created if you were following Zaitsev's rule. These are anti-Zaitsev rule products. So looking at the choices, if the base in the E2 reaction is sterically bulky and the approach to the alkyl halide is sterically hindered, the base will remove the most accessible hydrogen first. This is the second exception to Zaitsev's rule. And looking at these choices A, B, C, D, and E, the most sterically bulky base is A. So that is the reason A is the correct answer. Number three, third problem. Take a look at this. Which of the following statements is false? An E2 reaction. Okay, let's come back and take a look at this. Which of the following statements is false? An E2 reaction. So let's think about E2 for a minute here. Now, E2 immediately comes to mind is favored by a high concentration of a strong base. So B is true, it's favored with a high base concentration. Goes along with that is a good nucleophile, which is C, that's correct. E2 is favored by good leaving group, so D is correct. And it's helped along by a protic polar solvent, helps pull the leaving group off. So B, C, D, and E are correct. Now looking at A, E2 is a reaction in which the syn elimination pathway predominates. Well, anti-elimination is favored. Syn elimination is very slow since it requires an eclipsed conformation. Anti requires the more stable staggered conformation. So A is clearly the correct answer. Okay, look at this one. Under E2 reaction conditions, which alkyl halide will most readily eliminate? Take a look at this. Okay, coming back, let's look at why D is the correct answer. In an E2 reaction of a substituted cyclohexane, the groups being eliminated must both be in the actual position. And you'll notice that this would require both the hydrogen and the halogen to be in the actual position. And all of these others, the halogen, are in equatorial. So D is the only possible correct answer. Okay, let's look at the next one. In the reaction of bromocyclohexane with sodium acetate using acetic acid as the solvent, which would be the expected reaction pathway? Okay, take a look at this. Okay, let's look at why this is the correct answer. Best thing to do is to draw the structure of the bromocyclohexane. Of course, it's cyclic compound chair conformation you might want to use. With bromine and a hydrogen on adjacent carbons, turns out to be a secondary alkyl halide, which can do SN2 and E2 equally. However, acetate is a weak nucleophile and a weak base, which favors a substitution reaction. So it's reasonable with a good leaving group, weak nucleophile, and a polar solvent, as it says here, substitution will be the major pathway. Okay, look at this problem. A secondary bromide, of course I think the question really means a secondary alkyl bromide, was treated with DBU in ethanol. What reaction pathway would likely predominate? Okay, take a look at this one. Coming back, as you know, DBU is a bulky base used to encourage E2 elimination over substitution. So only the elimination reaction occurs with secondary alkyl halides. Primary and secondary alkyl halides only do E2. So E2 is the answer. Okay, let's look at this one. What is the major reaction pathway followed in the following reaction? Okay, take a look at that one. Okay, now let's look at this. This one is not quite as straightforward, but the ethoxy ion here is a strong nucleophile, so we can readily say it's going to be SN2 or E2. E2 will require an actual positioning of the bromine and the hydrogen on adjacent carbons before it can occur. So if you write out and show the structure as drawn here on the slide, the boat conformation, in order for these to be on the same side and this on the opposite side, both of these are up bromine is down. Bromine is actual. We could draw it actual, but for these to be in position as shown here, these two methyl groups will be in the actual position, which means that the hydrogens on these adjacent carbons to the bromine must be in the equatorial. If that's the case, then E2 cannot happen. And if it's going to be either SN2 or E2, and E2 is eliminated, then SN2 is all that remains. Therefore, it must be SN2. Okay, let's look at this problem. Take a look at this one. Read it. Which of the following statements is not consistent with an E1 reaction mechanism? Okay, take a look at that. All right. E1. Which is not true or not consistent with E1? The isomer predominates that has the largest groups on opposite sides of the double bond. That is a true statement, yes. E is more stable than Z. The Zaitsev product predominates, yes. This follows the Zaitsev's rule. The reaction is stereoselective. We know E2 and E1 are both regioselective due to Zaitsev's rule. They're also stereoselective. So D is correct. E and Z isomers are formed. Yes, they occur because of the double bond in the product. So we know B, C, D, and E appear to be all correct. So A, anti-elimination is the predominant pathway. This is true for E2, but not for E1. Therefore, A is false and not consistent with an E1. All right, let's look at this one. Which set of reagents will give cyclohexyl ethyl ether in high yield? By elimination, B and D are correct. A will be with a good nucleophile, strong nucleophile, will cause an elimination reaction. E2. Substitution will occur in the case of B and form the product that we're interested in, and also D will do the same. We have ethanol, which is the structure that's going to eventually be on one side of the ether, the ethyl part of the ether. And also C, A, C, C will result in a number of different ethers that could possibly form based on these two. So E is the better answer, B and D. Okay, in the reaction of 1 iota, 1 methyl cyclohexane with sodium acetate and acetic acid, which would be the expected reaction pathway? Okay, take a minute to look at that. So if you draw the structure of this cyclohexane with a methyl group and an iodine on one of the carbons, with sodium acetate, has a good leaving group. The iodine is a good leaving group. However, the acetate is a weak nucleophile, so right away we would propose SN1E1. We have a tertiary alkyl halide, which we know can do substitution or elimination. So of all these answers, substitution and elimination both is the best answer. That concludes our discussion of problems for Chapter 10.